Okay, I've set up one sensor and a current sensor, but I'm not quite there yet. So on this robot project, I have the Esp32, I have the I2C multiplexer working. The screen I couldn't get working. Turns out these are not I2C, the ones I bought, so I gotta get new ones. Accelerometer's working, and these are current sensors. I haven't yet got those up and running. So what I was able to do was create a larger project. So now I've got drivers for all the motors, sensors, some commons. This is the multiplexer, and then I created a more comprehensive web page. The main loop has, it's starting voltage, starting data collection, voltage sensor, not an initialize, so it skips the read. So I've done that, and then the front and back sensors are just dummy sensors while I get that up and running. But what I've been able to do is create it's a web page, right? So the web page acts as a control information. So here's the accelerometer. So if I move the accelerometer around, it behaves. It does, there's the gyro, there's the blah blah blah. Because those are not absolute values, those are acceleration and gyro values. They have to be interpreted. I can calibrate the IMU, so what it does is it says, please keep robot still and flat for a few seconds, boop, 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 boop. And then what it does is it calibrates a new offset, so it creates offsets. So check serial monitor for more details. Then I have BLDC, so I can't remember BLDC, a DC motor, big little DC motor, I can't remember. So you toggle enable, toggle forward, toggle reverse, apply the brake, release the brake, and every time you do that, you get a like a warning or a call. Then there's also I've got the hall sensor. I think it's HAL. Gonna have to check that. And then calculated RPM based on those hall sensors. Then I have H-bridge control, so this will be like the ankle start stop, and then you can, because it's PWM going to it, you can actually adjust the motor speed, and then forward, and then stop. But none of those are enabled. And then also the voltage and current readings. One of the things I was able to do, look, check this out. So it's got full API. So if I want to set the parameter for the type, this is the speed value, I can put the value in here. There's an emergency stop action. So if I have, let's say I had a Raspberry Pi driving the logic behind all of these things, I can set all of these parameters through just changing the command line. The other thing I can do is I can do /sensors, and there is a JSON representation of the values that are on the sensors. So it's been a lot of work, and of course emergency stop. Like, what good is a robot if you don't have an emergency stop activated, and disabling all the brakes and putting all that stuff in. This is on my GitHub, so I'll be crushing away at it for the next little while here. Big issue with the Esp32 is getting the platform I/O properly. So I had to do proper platform. Then I had to add all the libraries. Some of them are custom, so I had to do that. One of the things is the partition in the ESP32 is not big enough for my program, because I got a huge program, and also I was having problems with erasing those, so I had to write an extra script that ultimately erased everything. So anytime I go to compile it, it runs a Python script first that flushes the erases the flash effectively, and then loads all of this stuff, and then loads all of my dependencies and Arduino libraries and all of that stuff. So, yeah, it's been a big one. But look, website control of an ESP32 with an API. Incredible. I love this stuff. This is why I do it.